All right, so for the assignment during block 2, you guys are going to be working in groups, completing these 12 questions. There's 12 polynomial equations here. You are going to be asked to state the number of solutions based off the fundamental theorem of algebra, the possible number of real roots, possible number of imaginary roots based off the conjugates theorems, complex and irrational conjugate theorems, and then the possible rational roots off the rational root theorem. And then we would actually have to find all the roots, okay, real and imaginary. All right, so I'm just going to do a few of these. If you guys get stuck in your groups, you'll be watching this video to help you guys out here. So question 1, okay, I'm just going to use the snipping tool down here. And again, when you're working in groups, you might want to be someone wants to be sharing their screen. So if you go to the snipping tool, okay, on Windows, you could get this, hit new, okay, just select that, and then you can make this, okay, as big as you want, and then write on it and share it as a whiteboard. Okay, so right here, so I'm going to do this a couple ways. All right, so the first way here, if I start answering the questions, how many answers should I get? Okay, I should get 3 roots, okay, because that is the degree. So there's going to be 3 roots, okay, 3 solutions to this. Okay, some could be imaginary, some could be irrational, they could be rational. Okay, we don't know yet. All right, but since it's odd, okay, how many real roots can there be? Okay, so for real, okay, I know it's going to be either 1 or 3. It can't be 2, because if there was 2 real, that would mean there'd be 1 imaginary, and we know that imaginaries have to come in pairs. So for the imaginary, okay, it's going to be either 0 or 2. All right, if there's 0 imaginary, then there's 3 reals. If there's 2 imaginary, then there's 1 real. Okay, and the reals could be rational or irrational. All right, so that's going to answer those questions. Now we have to do our possible rational roots. Okay, so our P over our Q's. Okay, and this one's actually going to be really simple. All right, because our P is 5 and our Q is 1. So the only possible answers here that are rational are 1 and 5, plus or minus 1, plus or minus 5. All right, and so I have 4 possible choices here that might work. All right, so with that being said, we are going to try to find those using the rational root theorem first, and then I'll show you a different way next. Okay, so I'm going to set this up. My coefficients are 1, 5, -1, -5. All right, and then I need to start trying which ones might work, which ones might not. So if I try 1, right, I multiply, bring down, multiply, add, multiply, add, multiply. And so I did get a remainder of 0. So 1 is one of my roots. Okay, I can keep going. Okay, I could try again. All right, or okay, I know there's 3 terms here, so I could write this as a quadratic, x squared plus 6x plus 5 equals 0. And I recommend doing this because you don't know if the next 2 answers are going to be imaginary or irrational. So I could use the quadratic formula, or if I do notice, oh, this is factorable, what multiplies up to 5 and adds up to 6? That's 5 and 1. So x plus 5, x plus 1, all right, so then I get x equals -5, x equals -1, and then don't forget about the x equals 1 that we already had. So those are my 3 roots. They happen to all be real. All right, and so that's one way to solve this problem. Okay, another way, a second way to solve this problem was it's 4 terms. All right, I could see if factor by grouping works. So if I divide this in half, okay, I take out an x squared, and then I'm left with x plus 5. And I look at the next one, there's a negative. The only thing they have in common is a 1, so I'm going to take out a negative 1. That's going to leave me with x plus 5. And since the parentheses are the same, factor by grouping works. So x squared minus 1 is one parenthesis, and x plus 5 is the other. And so when you go to solve these factors, right, one is x equals negative 5, and add 1, square root of 1 is plus or minus 1, and so x equals plus or minus 1. So again, I got the same 3 answers, positive 1, negative 1, negative 5. All right, so that's how you could do, again, you could do this either way. All right, let's look at the next one. All right, so on this one, okay, x cubed minus 6x squared plus x plus 14 equals 0. Again, the degree is 3, so the fundamental theorem of algebra states that the number of roots will equal 3. Again, I don't know if they're real or imaginary, okay, but roots, okay, equals 3. That's how many answers I'm going to get when I solve this. All right, again, so it's going to be the same. So for real, okay, what are my possible real roots? My possible real roots are going to be 1 or 3. And my possible imaginary, oops, going to be if there's 1 real, then there's got to be 2 imaginary. If there's 3 real, there's got to be 0 imaginary. And these have to add up to your answer here. All right, and so what are my p over q's here? So again, not too bad on this one. A little bit more than the last one. Plus or minus. Okay, my p is 14. So 1, 2, 7, and 14. Q is 1, so that's easy. I don't have to, nope, don't worry about the Q. So I have 8 possible answers here. So as I set this up, okay, 1, negative 6, 1, and 14. And then I start trying. Okay, my choices over here. So 1, it's negative 5, add that up, that's negative 4, add that up, it's 10. Okay, so this is not an answer, but I do know that the point 110 is going to be on my graph. All right, so it's that I didn't completely waste my time because eventually we're gonna ask you to graph this, and so that point is useful. All right, so if I erase all this stuff, let's try another number. Okay, let's try negative 1. Bring down the 1, multiply negative 1. Okay, that's negative 7. Multiply by that, that's 7. That's 8. That's negative 8. And so that is 6. So again, no success, but I do know a point. Okay, so let's try another one. Okay, so if we try 2, add that up, I get negative 4. Multiply there, I get negative 8, negative 7, and then I get negative 14. And so 2 works. So one of my answers is x equals 2. All right, then I'm left with there's 3 terms down here. It's a quadratic trinomial. So I'm going to get x squared minus 4x minus 7 equals 0. And I got to solve for that. So here, nothing's going to multiply up to negative 7 and add to 4. I'm going to have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a and so I do 16 plus 28, okay, and I'm going to get 44 over 2. And so then I could simplify that radical. So it's 4 times 11, so that's 2 rad 11 all over 2. So x equals 1 plus or minus rad 11. All right, so my answers, x equals 2, and my other two answers, x equals 1 plus or minus rad 11. So again, these are three real answers. One is rational, and we have two irrational answers. All right. Another one, let's do number 3 here. Okay, this one looks pretty challenging. We got a 5th degree polynomial with some pretty big numbers here. Okay, so here, okay, how many answers am I going to get? I'm going to get 5 roots. Okay, it's a 5th degree. So the number of answers, the number of roots or solutions or zeros, right, will always match the degree. Right, now how many real? Okay, what are my possible number of reals? Okay, again, it's odd. So I could have 1, 3, or 5. They could either all be real, okay? 3 of them could be real, or 1 of them can be real. Because then for the imaginaries, which we know have to come in pairs, okay, I could have no imaginary, okay, and that would be if I would have 5 reals. I could have 2 imaginary, and that means I would have 3 reals, or I could have 4 imaginary, and that means I would have 1 real. All right, and then my P over Q's here, and not as easy. 98 is a pretty big number. All right, so we're going to get plus or minus 1. Okay, it's even, so 2 goes into it. 9 plus 8 is 17, so 3 does not go into it. 4 does not go into it. 5 doesn't, 6 doesn't, does 7. 7 goes into it. Yes, it does. Okay, so 7 will go into it 14 times. All right. 98, does 8 go into it? No. Does 9? No. 10? No. All right, 11, 12. So we're getting back down. So it's going to be 7 times 14, right? 2 times 49, and 1 times 98. All right, so those are my possible rational roots. Again, you could use a calculator there as you could just divide, okay, 98 by all the numbers, okay. And once it matches up like the 7 and 14, I don't have to keep checking 15 because I don't have anything else there. All right, so now I'm going to use the rational root theorem. So write out my coefficients, 1, -2, -14, 28, 49, and 98. -98, make sure you get your signs right as you're writing them down. All right, so if I try 1, get -1, -15, -15, that's going to be 13. This is not going to work, okay, but I'm going to keep going just so I get a point on my graph. I've already done this much work. 62. So that's going to be -36. Okay, so the point 1, -36 is on my graph. And then I'll erase all this. And then I'll try -1. negative 3, 3, negative 11, 11, 39, negative 39, 10, negative 10, so negative 108. I ran out of room right there, but so that's going to be negative 1, negative 108. Make that bigger. All right, let me erase all that. Let's try 2. Got a good feeling about 2. So 2, I get 0, 0, negative 14, negative 28, 0, 0, 49, 98, 0. So 2 does work. So one of my answers is x equals 2. All right, now I'm going to throw on my x's again. So now what I have here is I have a trinomial. I have a 4th degree trinomial right here. I want to see 4x to the 4th minus 14x squared plus 49 equals 0. I want to see if the quadratic pattern will work for this. And it does. All right, so I could divvy this up as x squared minus 7, x squared minus 7. And so it's the same thing. So I'm going to get multiplicities, right? It's going to be x equals plus or minus rad 7 with the multiplicity of 2. All right, so right there, that's 4 answers right there, right? Plus rad 7 twice, negative rad 7 twice, and then x equals 2. All right, so those are my 5 answers, 5 real answers. 1 is rational and 4 are irrational. All right, but it's 5 real, 0 imaginary. All right, so out of all these choices up here, only 2 would have worked. That's the only one that would have worked. Okay, I could have kept trying the rational root theorem right there. Okay, but nothing would have worked. So it was good that I recognized that this was a quadratic pattern. Okay, a 4th degree, but using the quadratic pattern. All right, let's try number 4. Okay, number 4. I'm going to go ahead, and there's 2 ways I could do this. All right, there is that it's the difference of cubes, which I'm going to use, but I could also use the rational root theorem to do this. Okay, but it's going to be quicker if we recognize that it's the difference of cubes. Okay, so we still got to answer all the questions. There's going to be 3 answers. All right, how many real can there be? So at most, right, it's going to be 1 or 3 again. Right, always when it's a 3rd degree, it's 1 or 3 real. Okay, my imaginary can be 0 or 2. Oops, did that again. Imaginary, okay, is 0 or 2. Again, right, 0 imaginary means there's 3 real. 2 imaginary means there's 1 real. All right, my possible p over q's here, okay, are just my factors of 64. Plus or minus 1, 2, 4, 8, 16, 32, and 64. All right, if I did use the rational root theorem, I'd have to set it up as 1, 0, 0, negative 64. And in this case, okay, 4 is going to work. 4 cubed is 64. I bring down the 1, right? 4, that's 4, that's 16. Bring down the 16, that's 64. and that's 0. So I'm left with this quadratic, x squared plus 4x plus 16 equals 0. All right, and the other answer is x equals 4. And so this one has to be solved using the quadratic formula. All right, and it's really fast. If I would have used, okay, the sum or difference pattern, the difference pattern of two cubes, right? 64 is 4 cubed, so it would have just been, x minus 4, and then x squared plus 4x plus 16 using the pattern, which if you notice, right, it's the same quadratic that I got using synthetic division. So it would not have mattered. It's just, again, but I got it on the first try because I knew 4 was going to work, right? If you didn't know 4 was going to work, the pattern is definitely easier than synthetic division because I didn't have to try 1, -1, 2, -2, and so on. But the quadratic formula for this one, okay, x equals will be -4 plus or minus, okay, 16 minus 64 over 2. So -4 plus or minus -48 over 2. Simplify that. I'm going to get imaginary now. So -4 plus or minus, that's 16 times 3. So that's going to be 4i rad 3 over 2. And then simplify. So -2 plus or minus 2i rad 3. All right. And so those are two imaginary answers right there. Combined with my one real rational gives me 3 answers. So in this case, it was 1 real, 2 imaginary. Okay, let's do number 5. Okay, number 5 right now. Again, it's a 5th degree. 5th degree is going to be 5 roots. All right, so again, for the possible real, it's odd, so it's going to be 1, 3, 5. For the possible imaginary, all right, if there's 1 real, then there's 4 imaginary. If there's 3 real, there's 2 imaginary. If there's 5 real, there is 0 imaginary. Okay, my P over Q's, okay, my possible rational answers, okay, always plus or minus. The 27, the factors of 27 are 1, 3, 9, and 27. And again, Q is 1, so I don't have anything there, no fractions to worry about. And so I'm going to set up my synthetic division. 1, -3, 10, -30, 9, and -27. All right, so if I start with 1, just do some work real fast. 8, -22, -22. All right, so that's not going to work. Again, I could keep going just for the sake of time, though. When we're graphing, you're going to definitely want to keep going. All right, what if we try -1? -4, 4, 14, -14. So that's -44, 44. Okay, so that's not going to work. All right, so let's try 2, or 3, I mean. And you get 0, 0, 10, that's 30, that's 0. That's 0, that's 9, it's 27, and so that does work. 3 does work. All right, it leaves me with this trinomial. That's a 4th degree trinomial. But I'm going to see if the quadratic pattern will work. So I get x to the 4th plus 10x squared plus 9 equals 0. And that is factorable. That is x squared plus 9, x squared plus 1. And so when I solve both of these, okay, I'm going to end up with, show you the work here, x squared equals negative 9, square root both sides. So x equals plus or minus 3i. Here I subtract 1, I get x squared equals negative 1. Okay, square root both sides. Square root of negative 1 is I, so x equals plus or minus I. And then the other answer was x equals 3. So again, I have 5 total answers. I have 4 imaginary answers, positive 3i, negative 3i, positive I, and negative I, and 1 real. So 4 imaginary and 1 real, and that real is rational. All right, so that one, again, 3 would be the only one that works out of that list of 8 different numbers up there. Let's do one more for you guys. An even degree polynomial. So this is the first even degree polynomial that I'm doing here. So this is a 6th degree. So how many roots am I going to have? I'm going to have 6 roots. When I'm done solving this, I better have 6 answers. All right, now it's even. So for my reals, okay, so we got to think an even degree does not have to touch the x-axis. So I could have 0, 2, 4, and 6 real. All right. And the reason why I'm not going with the odds, like the 1 real, that would have been a multiplicity, so that counts as 2. We're talking about the number of roots now, just not the number of x-intercepts. Okay, so multiplicities are implied in these numbers here. Okay, imaginary. Right, if I have 0 real, I'm going to have 6 imaginary. If I have 2 real, I'm going to have 4 imaginary. If I have 4 real, I'm going to have 2 imaginary. And if I have 6 real, I'm going to have no imaginary. Remember, imaginaries have to come in pairs, conjugates. All right. My P over Q's. All right, for 80, so that's 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. So that is a lot of possible answers here. All right, and so I can set this up. Okay, 1, 5. Oh, nope, that's wrong. That's wrong because there's no x to the 5th. So 1, 0, 5, 0, negative 16, 0, negative 80. All right, so there's my setup. Again, there's no 5th term, there's no cubic term, there's no linear term. So make sure you put zeros in the placeholders. All right, but really fast before I do that, I think that factor by grouping might work here. All right, so what do those have in common? X to the 4th. Okay, and then that's going to leave me with x squared plus 5. And then here I could take out a negative 16, and that's going to also leave me with x squared plus 5. All right, and so I'm going to get x to the 4th minus 16, x squared plus 5. And then x to the 4th minus 16 is the difference of 2 squares. Okay, that's x squared minus 4, x squared plus 4. And I still have x squared plus 5. And so when I go to solve all these, right, I add 4, take the square root. This is x equals plus or minus 2. This one will be x equals plus or minus 2i. And then this one will be x equals plus or minus I rad 5. And again, all I'm doing is subtracting 5 and square rooting it. So the square root of negative 5, right, because it's negative on the inside, the I comes to the outside, rad 5. Right, this one doesn't have a radical because square root of 4 is perfect square. So square root of negative 4 is just 2i, right? And that was positive to begin with there, so just no imaginary at all. So those are my 6 answers. I got 4 imaginary, and I got 2 real. So if I was going to do the rational root theorem, okay, I would choose, I'm kind of cheating now, but I would choose 2. Okay, and go ahead and work through that. Oops, 18. All right, and I'll keep adding. And then I get 80, and then I get 0. All right, so then I've got 6 terms here. All right, so I'm going to keep going. All right, and since, again, I know it's going to work, okay, I'm going to go ahead and plug in negative 2. Again, I know it's going to work because I already solved it using factor by grouping. Bring down the 1, all right, multiply, add, multiply, add, multiply, add, multiply, add, right? And then I get 0 again. And now what am I left with? Now I'm left with x to the 4th plus 9x squared plus 20 equals 0. So this is quadratic pattern now, x squared plus 5, x squared plus 4. I already have my 2 answers over here of x equals 2 and x equals negative 2. And so again, you notice that it's the same thing over there. So I'm going to get the same exact answers. Okay, so x equals plus or minus I rad 5, and x equals plus or minus 2i, combined with my other 2 answers, x equals 2, x equals negative 2. So in this one, right, recognizing factor by grouping is a little bit easier just because you don't have to worry about getting wrong answers, okay, when you're guessing your rational roots. All right, and so that's 6 examples of how to use the rational root theorem combined with special cases of factoring to solve your rational, any polynomial, okay, for rational and imaginary roots.